Hey all, so welcome to your first real lessons that are going to be new material in this hybrid model. For those of you who are doing full distance, it'll feel the same. For those of you who are in distance today, it will feel the same. The goal is that for those of you who are at home on any given day, that the class doesn't feel any different than it has in the months previously. If you're in person, you're just getting more time to answer homework questions, get help from me, and get the work done while you're in school. So if you're at home, get yourself ready for notes, and we are going to get started. This is going to be a 2-day lesson. You've got 2 worksheets for homework, because the book work, from my perspective, is not exactly aligned with the way that you'll be expected to do this in lessons going forward, in classes going forward, intermediate algebra, advanced algebra, and so on. So we're going to go through that more sophisticated method, but I'm going to give you a couple days to work on it. So the first one, we're going to start today graphing in slope-intercept form. Now, if you maybe recall from our lessons in 10.5, you did see slope-intercept form a little bit. Slope-intercept form is any equation where y is equal to mx plus b, and this will always form a line. In this case, m is the slope, right? And if we remember slope from our review on Monday, as well as from our lessons early in the year, m is equal to our slope, which is rise over run, right? The amount that it goes up and down versus over, it's the difference in the y values over the difference in the x values. So up or down can be positive or negative. Rise, we always like to go left to right. Now, b in this case is the y-intercept. Now, what the y-intercept means is that it's where the line crosses the y-axis. So if I have the y-axis like this, the intercept is the point where it crosses that line, and it's always going to have an x value of 0, and then the y-intercept is b like this. Now, when we're graphing in y-intercept form, we're going to start out just like this. So what this tells us is that our slope is 2/3. So rise over run, and then 1 is our intercept, using this formula right here. The multiple of x is our slope right here, and then the constant that doesn't have x, so this is times x, and this is our constant, so no variable. When I go through my steps to graph, I'm going to start by plot the y-intercept on the axis. So in this case, it's +1. So I'm going to go to the y-axis here, and I'm going to make a point at +1. If you're using your own graph paper, just draw a quick grid and plot a point at +1, just like that. Now the next point I'm going to draw is I'm going to count my rise and run from the intercept. Now this is the important part. I see a couple students every year making this mistake. They'll start counting randomly from a different point. What I'm going to do is start at my intercept point right here that I just drew. And in this case, it says that my rise is 2 and my run is 3. My slope is 2/3. So my rise goes up 2. So notice I'm starting at my point. I'm going to say rise, which is up 2. And then my run, which is over 3. So I go 1, 2, and counting the spaces, 1, 2, 3. And that's going to be my slope. And I am going to connect that with another, that's where my next point is going to be. So then all you need to do is draw your second point and connect. because all you need is 2 points to draw a line. Now it's going to be a line, not a segment, so I'm going through those points and drawing arrows like so. If I wanted to draw more points, I could keep counting the slope up and over and it would be the same. And I could make perhaps a little bit of a neater line, but it's fine as is. There is our line y equals 2/3 x plus 1, so that we don't have to use a t-chart. Now this method works even when things don't look perfectly like rise, run, intercept. So let's look at number 2. F of x is equal to negative 3x minus 2. So here we want our slope to be a fraction, rise over run. Well, negative 3x, if I want to write that as a fraction, is just negative 3 over 1x, then minus 2. So in this case, my rise is negative 3 and my run is positive 1, and negative 2 is my intercept, because it's the constant without the variable. Now another thing you'll notice is that we had a y here and f of x here. Those are the same thing, and we will talk about this continually in the next chapter. F of x is the same as y. They are interchangeable. Whichever one you see, you treat them just the same. So in this case, I'm going to go through these same steps again. First thing I'm going to do is plot the y-intercept. In this case, it's at negative 2. So notice I'm going to go at negative 2 down here on the y-axis. Then I'm going to count my rise and run. Now it's negative in this case, so my rise is going down negative 3 and over just 1. So my next point is going to be here at 1, negative 5. If I wanted to keep counting the slope, I could. Just to draw myself additional points, you can also count it backwards. So all of these have the same slope in between them, which is down 3 over 1. So you keep going, down 3 over 1, down 3 over 1. Just if you want to make yourself a little bit neater of a line. But when you draw your way through, just draw through all the way and add arrows on the end, like so. Sometimes the line will not even really look like a line. It doesn't look like it has any numbers involved. And that's all right, because again, we are going to rewrite it. So I want to have a fraction multiplying x, and I want to have plus a number for my intercept, because this fraction is going to be my rise. This is going to be my run. And whatever number we have here has to be our intercept. Now, what number can we add that doesn't actually count? It doesn't matter. Well, that means that has to be 0, because 0 is what we can add without actually changing the value of the variable. What can we multiply here without changing the value of the variable? Well, that's 1. So then we have 1 over 1x plus 0, and that's going to give us our line. When we have an intercept of 0, that means it's going through here, which we call the origin, and then up 1 over 1 would take us here, counting. So up 1 over 1 for my slope, up 1 over 1, and I can keep counting. If I want to give myself a couple points to go through, I could go backwards. And that's going to create our nice diagonal line straight through the origin. Whoop. Sometimes if I hold my pen still for too long, it becomes perfectly straight, and we all see I'm not drawing as well as I want to. But there's our line, y equals x, straight through the origin, like that. Now, these are all sloped lines, right? They're going at angles, either going positive slope or in this case negative because we're going down. There are also lines that look like this that only have one variable, and we can still graph those. So let's look at those examples here. We have graph f of x is equal to 7. So this would be y is equal to something x, and we still have the constant plus 7. What could I have made disappear here? Well, it was 0. So in this case, we have y is equal to 0 over 1x plus 7. So we can still use our slope-intercept form. Plot 7 here. If our rise is 0, it doesn't go up and it doesn't go down, so it stays completely flat and just goes over 1. So we're just going over 1. There's no up or down. Over 1, over 1. Notice the kind of line we're drawing is a horizontal line. So when m is equal to 0, you're always going to have just y is equal to the number, so no x value. Just like this, it's a horizontal line. Like so. Now, if you have something where x is equal to -3, right? If you've got x is equal to a number, so there's no y or f of x, that means that you have a vertical line. Now, here's the important thing here is that if we have a vertical line, we have x equals -3. This is our x-axis. This would be -3. It's a vertical line. The slope has no run. So it has 0 for a run. It doesn't go over left or right. And whatever the rise is, we can't divide by 0. So the slope of a vertical line does not exist. So this gets us all the way back to one of our first lessons, that you can't divide by 0. But what we can have is if you have x equal to a number, you go on the x-axis, you plot that point, and you draw your vertical line like so. You'll have 2 days to practice graphing on the coordinate plane using the lessons from today and earlier in Chapter 10. And if you have questions on any of them and you're at home, please log into your class's Zoom time. You can also send me any questions in the emails, nominating them in the forms, or leaving something in the comments.